Welcome to today's Explainer. We're going to completely unpack the science, the sheer scale, and the devastating consequences of nuclear weapons. We hear about these massive geopolitical deterrents all the time in the news, but today, we're stripping away all the politics. We're looking directly at the underlying mechanics and the terrifying planetary aftermath of these devices. So, here is our roadmap for today. We'll kick things off with splitting atoms, then move into the stages of detonation, examine modern arsenals and MAD, and finally, we'll look at the ultimate aftermath in the nuclear winter.
All right, Section 1, Splitting Atoms, the Mechanics. To really grasp the massive destruction of these weapons, we've got to first understand the tiny, completely invisible reactions that actually power them.
Now, to understand the truly staggering scale we're dealing with here, just look at the energy difference. A standard conventional explosive, think of a single molecule of TNT, releases about 10 electron volts of energy. But a single uranium-235 nucleus undergoing fission, that releases 200 million electron volts. Let that sink in. That means a single nuclear fission event is roughly 20 million times more powerful than a conventional chemical explosion. We're talking about an entirely different rulebook of physics here. And that immense energy is unleashed through a process called fission. When a neutron strikes a heavy nucleus like uranium or plutonium, it literally splits it apart. But here's the catch. It doesn't just release kinetic energy and heat. It ejects 2 or 3 more neutrons. Those new neutrons immediately go on to split other nuclei. It's like a microscopic break in a game of pool, but moving exponentially. Within fractions of a second, this chain reaction amplifies into unimaginable kinetic energy.
Moving right along to Section 2, the stages of detonation. Let's see how this subatomic energy actually builds into a catastrophic physical blast. Get this. Because you have billions of fission reactions happening simultaneously, the temperature inside the bomb just before the blast reaches a staggering 10 million degrees Celsius. I mean, that is literally similar to the core of the sun. This intense heat instantly converts the bomb itself, its internal components, and the surrounding air into a rapidly expanding ball of superheated plasma. If we're looking at a modern 1 megaton blast, the destruction expands outward in terrifying, distinct stages. Within a 1.6 kilometer radius, everything is just instantly vaporized. Go out to 5 kilometers, and heavy, reinforced concrete buildings are completely flattened by the initial shockwave. Extend that out to 11 kilometers, and the thermal radiation is still so incredibly intense that it spontaneously ignites fires and causes third-degree burns. And actually, what's even more terrifying is the reverse blast that follows. The surrounding air violently rushes back